So today we're talking about special functions part 2. So yesterday we talked about absolute value functions and constant functions. Today we're going to talk about step functions and piecewise functions. So this one says, a recycling company pays $5 for every full box of newspaper. They do not give any money for partial boxes. Draw a graph that shows the amount of money for the number of boxes brought to the center. So we're talking about increments of how many dollars? 5. So $5, then $10, then $15, then $20. That's about as far as we need to go for my step function. All right. So do I get any money if I have half a box?
No.
That's right here. 1, 2 boxes, 3 boxes. So this is my dollar amount, and these are my boxes. 4, 5, 6. All right. But when I get a whole box, here you go. If I have a whole box, how much do I make off of that?
You make $5.
I make $5. If I have 1.5 boxes, how much do I make? $5. What if I have 1 3/4 of a box? $5. And 1.99 of a box? $5, right? Infinitely, it's $5. But what happens when I get to 2 whole boxes? It jumps up to $10. So when I'm here, it's no longer part of my function because I now have $2, so it steps up. I'm sorry, I have 2 boxes, so it steps up to $10. So what happens? Oh, did you get it?
Yeah.
Oh, okay. So what happens if I have 2.5 boxes? $10. Any amount in here, right?
Yeah.
Until I get to 3, and it steps up to $15. And the nice thing about step functions is once you get an interval like that, they're all even. You're not going to get an interval like this, right? This is an interval, these little pieces. I go from 1 box to 1.99999 boxes, and then I step up. 2 to 2.999, and then I step up. Okay? So far, so good? So I could continue in this fashion without even thinking about it, right? No thought involved. Keep going infinitely, unless they told us that there was an end. By the way, that would be a range, right? A range where you stop. Like, let's say, I'm not paying you after $100, so the range would be all numbers that are less than $100, or greater than my domain would be any amount greater than what?
1.
Good job. My domain would be, I would have to have more than 1 box to get anything, right? I'd have to have 1 box, x, such that x has to be at least greater than or equal to 1. Doesn't matter. Half a box is not going to get you anything. And my range, it doesn't say. Well, it does say one thing. What would my range be? Actually, y such that what? Greater than, y? Are you ever going to get more than, less than $5? You'd have to have a whole box, or you're out of luck. Y such that y has to be greater than or equal to 5. So far, so good? Let's move on. Pencils down. So that's nice and easy, but now let's talk about this idea of the greatest integer function. The greatest integer function is a step function, okay? So it's written like this. F of x equals the greatest integer of x or less than or equal to x. So an example of this would be the symbol of the greatest integer function means the greatest integer less than or equal to x. Isn't that very confusing? Right? So what is an integer? It's a number that's on the number line. Are fractions on a number line?
Yes.
No.
No.
Fractions aren't on a number line. So, for instance, if I were to, well, let's just dive into this and then we'll talk about a number that is an integer that is less than or equal to x. Okay, so from our behavior of graph, what should this look like?
To the left one. Up one.
Up?
Right one. To the right one. To the left one.
To the left one, right? When we have anything that's like this, haven't we learned? It looks like this. Okay, that was with parabolas. What about absolute value functions? The difference between 1 and -1, right? Means that we shift over to the left, right? That's what we've been doing for the last few days. Okay. So, if I have this, it means you're shifting. How come when I start a new lesson you guys don't get it, but when we talked about it here, you're like, totally. Right? Shift to the right, and then up, right? So this one would be shifting over to the left one. All right, so that helps me out because it gets me a starting point for my step function. So I'm going to shift over. Let's see if that's true. So I'm going to say I have a greatest integer function of x plus 1. And when I substitute a value in for x, I'm going to get a value for my function. So let's put in that -1. -1 plus 1 is equal to 0, and that's true. Let's plug in, substitute in 0. I get 1. 0, 1. Let's substitute in 1. I get 2. Stepping up, right? Let's talk about if I put in a half. Let's substitute in 0.5. What would I get?
1.5.
This is where this comes in. I get 1.5. Is 1.5 an integer? No. The greatest integer less than or equal to. Does that mean I can round up? What does less than mean? I have to round down to the nearest integer. So if I were to substitute in 0.5 for x, and I would go up to 1.5, there's no step there. It falls down to 1. It's the step down. It's almost like I have half a box of paper. Well, that's not going to get me enough to get to the next interval. Okay? So, just like those boxes of paper. So, let's see, if I put in 0.75 plus 1, I'm going to get 1.75. Is that a whole number?
Oh.
No, so it drops down to 1. Infinitely, there's a whole bunch. Just like I said, a whole bunch of papers in a box until you get to the whole box. And then once you get to the whole box, you step up. Same thing here. Then you step up. Same thing here. Then you step up. It's also going in the other direction. Make sense? It's a little foreign, right? But it makes sense when we talk about it in context of that newspaper example, right? Okay, let's move on a little bit. Here are my steps. Yeah, that's all I need. I've got my step function. I could go in infinitely down here, right? Okay, let's talk about our domain and range. Unless something told me that I had to stop somewhere, I could go in either direction. So consider the behavior of the graph. That kind of gives me a starting point. Don't worry if you can't do that, because then you just have to plug in a value and see what you get, and then you've got a starting point, right? But it's good to be able to know where we could start. Draw a table. Look for whole numbers that are less than or equal to x. I say whole numbers because when you start talking about negative values, it gets complicated. Now, don't let me confuse you too much, but let's talk about if I were put in negative 1.5. I would get what?
Negative 0.5.
Negative 0.5. What is the next number that is smaller?
0.
No.
Negative 1.
Negative 1. Right? So if I were to substitute in negative 1.5, I would get 0.5, right? But I can't, there's no step there. There's no support. So it falls down to negative 1. So I suggest you stay away from the negatives to begin with. Just work in the positives. The interval, once you get the interval, you know what it looks like, and then just draw the rest of it, okay? Because you get stuck in those negatives, and it's going to get confusing. What? Yes. This is what we're doing. Okay, I'm going to do another one for you. So the behavior of the graph, which way am I going to shift? Positive 3.
3.
Okay, so here's my function. My step function is x minus 3. Let's substitute in 3. 3 minus 3 is 0. I'm right. What would be another number I could use? Let's try, I'm not going to go 0 because that's a big jump. Let's just go 1 next to it, or 4, or negative, or 2. Let's put in 2. 2 minus 3 is negative 1. That's an integer, right? That works. So 2, negative 1. Try one more. 1 minus 3 is negative 2. That's an integer. That works. There's my interval.
That's pretty much all we have to do.
It gets a little harder.
Yeah, but for this style, this is what we do.
It gets a little harder. Oh, you know what I forgot? My domain and range. Step functions is easy. Do I have an order pair if I'm at 0 on x? Yes. What about at 1? Yes. And 2? And 3? Eventually, right? It's always going to keep going. So what about in the negative direction? It's going to keep going, right? There's always going to be an ordered pair somewhere. So this is all real. And my ranges, if I go up 1, up 2, up 3, am I always going to have a value in order pair? Yep. And if I go in the negative? Yes. And step functions, I can't think of an instance right now where it wouldn't be. But don't quote me on that one. Okay, so this one you guys have too. Okay. Graph each function, identify the domain and range. Consider the behavior of a graph. Okay, can't this also be written like this? 1/3 of x. What does that look like on a linear function? What happens to a graph? It goes closer to 0 because it's a fraction, right? So this is going to be a function that is kind of more lazy or closer to 0. So what would you plug in here? Let's write this all official here. Step function of x divided by 3, f of x. So if I were to substitute in 3 for x, I would get 1, 2, 3, 1. What would be the next value you'd put in? I would put in 6, but look I don't have a 6. So go the other direction. How about, we'll get there. About 0. Isn't that an integer? It's on the number line, right? So if I substitute in 0, I get 0. Let's try another one. What? Negative 3. What do I get if I have negative 3 over 3? Negative 1, negative 3, negative 1. You see a step? There's my step. There's my step. Keeps on going. I wish I had used blue. All right, now this is where this might make a little bit more sense. For instance, if I were to, let's say, substitute in 1 for x, what would I get? What would my output be? If I put in, substitute in 1, what would I get out? 1/3. So 1/3. Did I make it up to the second step? Nope. I'd fall back down. What if I put substitute in 2? What would I get? 2/3. Did I make it up to the next step?
Nope.
Nope. See how it makes sense? It's a real long step. And then once I got to 3, then it jumps up. Okay? You see how that example in the book is nothing like this?
Yes.
This is a lot more abstract. Okay. What is my domain and range on these? Yep.
I don't want.
You have to think a little bit. All right. So far, so good? What about this one? What do you think? All real. Consider the behavior of the graph. Somebody tell me what's going to happen with this graph.
It's going to be
It's going to be steeper. Got it? It's going to be steeper. So, what could you plug in?
0.
I would plug in 0 first, right? Where do you think your starting point's going to be if you start at 0? 0, 0. Let's do this right this time, and we're going to need it with this one. I'm going to use blue. Okay, 0, 0. So I'm going to choose 0, and I get 0. What do we want to put in next?
1.
1. Let's not jump up too quick, right? I put in 1, and I get 2. Over 1, up 2. It's really steep. It's so steep I need a ladder to get up to the next step. So, want me to do -1? Perfect. 2 minus 1, or -1 would be -2, -1, -2. Those are some pretty big steps. What if I told you can't step up that high? What could we do?
Get a ladder.
Check this out. How would I meet in the middle?
So, I guess
1/2. But I thought you told us, Mrs. Muller, that it can't be half numbers. Well, you can have an x value be a half, because look what happens.
you get 1.
You get 1. If I go over a half and up 1, is there enough support there for a step?
Yeah.
Yep. You feel it now?
Yeah.
So this graph would look like see that?
Oh, yeah.
I get it.
Get it?
That's abstract.
It is abstract.
Out of nowhere.
Right? You can plug in or substitute in a half. What if I had 3x? How many intervals would be between 0 and 1? That's 3 of them, right? You'd have from 0 to 1/3, then from 1/3 to 2/3, then from 2/3 to 3/3, right? There would be 3 little tiny steps. You guys got it? What's my domain? Was I right? You just have to give it a second. It's something new, but once we look at it a little bit, your mind got a chance to absorb a little bit of it, and it makes a little bit of sense now?
Will it always be numbers? I mean, I thought it was going to be like extremely hard.
Okay, good. Well, it's always, more pleasant when you think it's going to be really bad, and it's not so bad, right?
Okay.
All right, let's jump up to piecewise functions. Okay, we're okay? We're okay, right? It looks scary. It's not that big of a deal. Okay, so all this is really saying, guys, I'm going to write it over here. All this is really saying is a function that has two different conditions. A function, we'll write it in, we won't even use the function notation, I'll just use y. It's saying I've got this one, and I've got this one in the same function, on the same graph. That's what this says. It's just really fancy at the same time. Okay? Both of these are conditions on this graph. All right? So, x plus 2, actually before I do this, all right, so let's consider y equals x plus 2. We all know how to graph that, right? That's a linear function right there. I start at, my y-intercept is at positive 2, and I have a slope of up 1 over 1, or in this direction. I'm going to draw myself, I suggest you do this in pencil, and you'll see why. Okay, this says the function of x, where x plus 2, if x is less than or equal to negative 2. So that means I have to go back and say, I need to only consider when x is less than or equal to 2. Where is x less than or equal to 2? Right here. So can x be 1? Can x be 0? So guess what happens? Does that make sense? I just said x can't be greater than negative 2. It's got to be less than. Okay, let it sink. Let it sink. It's not going to come to you right away. Let's do the next one. Change my color. I know it should. Y equals 3x. What does that behavior look like? Steep. Steep, right? It starts at 0, 0, because there is no y-intercept. Shh, guys, I need your attention. It starts at 0, 0, and it has a slope of 3. 1, 2, 3 over 1. Here's my line. Make it orange. That's not orange. There we go. All right. What are my restrictions? X has to be greater than negative 2. Here's negative 2. Here's my graph. It has to be, it has to be greater than negative 2. And this right here needs to go like that. It's not exactly on, but you guys get the idea. Right? 3x. So line 3. It's confusing. You've never seen it. Just open your mind. It will sink in. Just give it another example or two. This is the first one, right? So 3x is a line that you are all familiar with. But in this particular function, it is only going to work. It only functions if x is greater than negative 2. Here's where x is at negative 2. Here's my orange graph. So the only things on this line that are going to work is where it's here and greater than. All the things that were less than no longer can be considered. My line breaks up. That's why they call it a piecewise function. Okay, it'll come, I promise. All right, so let's talk about our domain. Do I have an ordered pair at here? In this direction. Do I always have an ordered pair? Do I always have an ordered pair in this direction?
No.
No. Do I have an ordered pair here? 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 Always, right? Is there an order pair if X is both of them? That's why they're both involved. That's why you've got a bracket.
Oh, yeah.
Right?
Yeah.
You got to consider both of them.
Yeah.
Okay, so if I'm going in this direction, yes. This direction, yes. So no matter what, these are the ones that are tricky on the piecewise. You'll see them. We're going to see it right now. Okay? Let's talk about Y's. Am I always going to have an order pair? Going up and going down. It may stop here, but then look, it keeps and continues on this line. This graph takes over, right? This one, when I get to here, it stops, but this one starts back up, and I'll always have an order pair with the blue line. So this one is also all real numbers. I'm not going to take questions yet. Let's do another one. 4 minus x. Don't let that scare you. That's just negative x plus 4. Correct? We all know how to graph that. Let's graph that. Negative x plus 4 starts at 4, and that's a negative slope, up 1 over 1, up 1 over 1, like this. Go ahead and draw myself a line for my function. Now let's consider, let's just get rid of this. Let's consider this right here. X has to be greater than 0. Here's where x is 0. Here's my graph. X has to be greater than. Not greater than or equal, it has to be greater. So I'm going to take this line, I'm going to make sure change it. So it has to be here or greater. Now I understand this line is going down, but this is just like saying as the temperature decreases, hot chocolate sales increase. Right? That's what that's saying right there. Right?
Yeah.
It's going down, but really, aren't the cups of chocolate getting greater and greater and greater and greater? Okay. Let's consider the other one. We're not done yet. So negative 2x minus 2, that starts at 2, and I go, it's also negative, right? Up 2 over 1, or down 2 over 1. Here's my, oh, oopsie. Thank you. So all I have to do is what? Shift it down? Look how that happened. I just shifted it down. Isn't it the same slope, only shifted down 2? Right? Do you need me to do it? Down 2, up 1 over 2, up 1 over 2, right? Behavior of graph, right? Just shift it. Okay. But here is our restriction right here. X has to be less than 0. Here's where x is 0. Here's my graph. Has to be less than 0. Less. Sorry. You guys are on it. No, hold on. Hold on. See, you guys are smart. You caught it. So it has to be less than 0 is in this direction, right? So that means that, boys, stop talking, please. That means this one has to be going this way. See how it's hard to figure out which one's going which way? See that? Now let's talk about domain and range. When x is 0, do you have an ordered pair? There's not one there because it's not including 0, and there's not one there because it's not including 0. Is there one when x is 1?
Yeah.
Is there one when x is negative 1?
Yeah.
X such that x, you could say is greater than 0 or x is less than 0, or you could just say is not 0. Because it works for every other value, right? Except when x is 0. What about the range? As I'm going up, do I have values? I have 2. 2 ordered pairs. 2 ordered pairs. What about here? 1 ordered pair, 1 ordered pair, 1 ordered pair, yes. I can't hear you. Then it would be, that's a very good question. What if it looked like this? Then it would be all real numbers. Got it? So this one is, I wanted that to be a different color. All real numbers. Because when we're going on the x-axis, we will always have an ordered pair, except for there will never be an instance where you could put x is 0 and y is, we can't. There will never be it. You can't have x be 0 here, and you can't have x be 0 here for either one of our pieces of our graph. Okay? Let's do one together. Together. Don't let this, okay, if this scares you again, didn't I say this just means y equals? So this means y equals 3 and y equals x plus 1. What kind of line is y equals 3? So horizontal line. So isn't that just 1, 2, 3? Isn't that just this? But x can't be less than 1. Here's where x is -1. I'm sorry, x can't be less than -1. Here's where x is -1. So x cannot be any less than that. So what happens to that line? It gets erased.
Because x is positive on that side.
X is positive. It's going on forever. Less than if x is, you're right. I totally did that on purpose. No, I didn't. Extra credit. You guys are awesome. You're on it. I'm really, really surprised. Yeah, you guys are on it more than any of my other classes today. Or I've just taught it so many times today that I'm flipping. No, I taught it the right way. I'm getting tired. It's 6th period. I've said this 3 times today, which is not an excuse. There's only 3, but that's not an excuse. It shouldn't. You should get the same education as everybody else, right? Okay, so. And yeah, it's perfect. I'm making all the mistakes when I'm taping it, right? So x is less than -1. Here's where x is less than -1. This is where it's less. Let's finish this up, guys. X plus 1. So let's change it to, I'm going to go up 1, and then it's up 1 over 1, up 1 over 1. Go ahead and graph that. X has to be greater than 1. Here's where x is greater than 1, right here. So I need to erase. Am I right? Am I doing it right? Yeah. Okay, good. I am asking you. I'm tired. Okay. I can't even find my tools anymore. There we go. Okay, so x is greater than 1. So let's talk about domain and range. Is there any time when I plug in, substitute 0 in, and I'm going to get an order pair? No. No. What about at 1? Yeah. No. It's an open circle, right? So x has to be what? No. Greater than 1. What about in the negative direction?
Has to be less than -1.
Or x has to be less than -1. You guys are like almost excited that you actually have something other than all reals, right? No, not really. Okay. All right, this is where it's all going to come together. Check this out. Do I have an ordered pair when y is 0?
No.
When y is 1?
No.
When y is 2?
No.
But when y is greater than 2, I do. Right?
Because it starts at 2.
Starts at 2, and it goes up. And it keeps going up, right? All right, good job, guys. What did we learn today?
And I trusted you and you lied to me about what the thing was.
Oh, my goodness. You guys are
I trusted you, Nicole.
okay. I do have a 3-hole punch. Guys, please stop shuffling. I want to talk about this. Oh, there's the bell. Bye, guys.